But today we're actually going to talk about oil cleanliness best practices and why Adams feels like this is very important to you as our customers and also to anybody else. So just off the bat, Adams is a big partner with our manufacturer, Hypro Filtration. Hypro builds filter elements for just about any application in the field. They make drop-ins for everybody, whether it be Parker, Schroeder, Paul, whoever. They make a drop-in for it. Today's not going to be solely around manufacturer. This is more technology based. It's not going to be heavy manufacturer product stuff. So we don't want to bore you with what all Hypro has, but just be aware that we are partnered with Hypro from the get-go with filtration and also contamination equipment. So Adams does sell new contamination equipment, and then we also rent out equipment as well to help you if you have anything come up and you need to get something to clean up your system. Also, we believe in oil cleanliness so much that we've hired in the last 7 months a oil cleanliness specialist. His name's Norm. So me and Norm work together, helping customers look at ISO codes, water issues, and varnish issues, and helping them understand oil reports, doing trainings with our customers so that they can be brought up to speed on oil cleanliness. So why do we feel like oil cleanliness is important? Adams works with a lot of heavy industries in the state of Florida and in Alabama, whether it be mines, paper mills, sawmills, power plants, cement facilities, or either metal production. All these plants have found out that by lowering their contamination in their systems, everything lasts longer. And when things last longer, we improve uptime, and we also get rid of unplanned downtime, which are big killers in the industry. So why are costs of downtime important? Well, there's a lot of different things that come into costs of downtime. You've got detection costs and contamination costs, third-party costs, business costs. All these things start to add up and start to put a hindrance on the customer from a revenue standpoint. So let's jump right into it. What are the types of contamination that we are looking at? First off would be particles. So most people think of it as silt or sand or anything that could get into their system as a hard particle and do some destruction. Water is another one. Causes a lot of corrosion and premature failures. And then the last and the newest, and I'll use this buzzword, it's varnish. But it's basically the breakdown of the oil when it starts to oxidize. So let's start off with particles. So first off, you want to know if you have particle contamination in your system. So things like sticky valves, cylinders working sluggishly, or machinery working sluggishly, can start to affect you and can start to give you an indication that, hey, there might be something in my system that's causing an issue. So on the bottom of the screen here to the, I guess it'd be on the left side of the screen, you can see a particle as it's going through two wear surface areas. In hydraulics, the hydraulic fluid is used as a lubricant. So I like to use the analogy of you can have rough sandpaper going through your system, changing those tolerances in your system, or you can have a real fine sandpaper. Which would you rather have making contact between your surfaces in your system? Just remember your oil in your system is like the blood in your body. It's the driving force of everything. If it's not clean, it's not going to work correctly, just like what you have in your body. Now, another thing that I like to start off with is the chart showing micron size comparison. The reason I show this chart is when you first walk into a customer, sometimes they just think, hey, let me go pull a sample, and they bring it and they give it to me and they say, look, we're clean. And I'm like, well, honestly, I don't know, because I'm looking for particles I can't see with the naked eye. So just on the far side there, you got a coffee bean size. It's about 400 microns. Going down the line, salt, hair is supposedly the smallest particle the naked eye can see, and it ranges 50 to 70 micron. One that's near and dear to our hearts here in Florida is that pollen. It's 30 to 50 microns. And then you see, we're thinking of particles in the 8 micron range, and that's a red blood cell. So that just kind of gives you an idea of how to wrap your head around when we're talking particles. We're not talking stuff you can visually see. We're talking about stuff that you're not going to be able to see, or just hold up a sample to the light and say, look, we're clean. So now that we kind of know what our indicators are for we might possibly have some particulate contamination, where did it come from? You know, my lube oil system or my hydraulic system is a closed system. Nothing can get in. Well, that's true and not true. So you got that built-in contamination. You got a cylinder, rod wears, and contamination can get through the rod seal. The fabrication of that system may have induced a bunch of particles that you weren't aware of. Then you got external ingression. Bearing seals, reservoirs that have breathers on them that haven't been looked after or have been removed and not put back. General contamination, assembly, breakdown, moving equipment from one side of the facility to another. Then you got maintenance contamination. This is one that when I started about 16 years ago, kind of laughed at. I never thought that anybody would put rags into a hydraulic system, but it happens, and I've seen it. You know, we have issues where the pump's cavitating and there's a rag inside the reservoir wrapped around the inlet to the pump, and it's not letting the pump grab that fluid. So as I used to laugh at it, it's not funny, because it actually does happen. One that has really shown its ugly face to us here lately has been pipe assemblies. Customers have gone in and repiped systems, and I found this online. I'm not quite sure who the editor was on this one, but they said just screwing pipes together for a new system could induce up to 60,000 5-micron particles into a system that you're not accounting for. You're cutting that pipe, you're doing your best to keep things clean, and you think, oh, it's new pipe, I'm not going to have any contamination issues, and lo and behold, you do. And then probably the biggest misconception that we hear a lot is that new oil is clean oil. Some customers are like, well, hey, my oil gets contaminated, I'm just going to do a dump and flush, and then I'll just add brand new fluid into the system and we'll be good to go. You know, the refinery process of oil is in itself dirty. Once it comes out of the ground, it goes to a refinery. Then from a refinery, it may go to a holding tank. Then it may go to another holding tank, then to a truck, then to a barrel, and then now it finally gets out to your system. Unfortunately, they're not filtering this oil from any of those processes. So making sure that before you put that oil into your reservoir, you filter it is probably a great way of taking the stress off of your online filtration and your applications. So we've talked about where contamination has come from, how to tell if you have contamination. Let's talk about how in the industry we quantify how your system is contaminated. So we do that by ISO codes. And an ISO code is a 3-digit code. You can see there in the middle, the code number for this first one is a 242219. Each one of those codes relates to a range of particles. So the first code would be your 4 micron up to a 6 micron size. Then your second code is your 6 micron up to a 14 micron size. And then your last code is a 14 micron all the way out. Now again, if you look at the chart where it shows your code range there to the left, and it shows how many particles are within that range. Let me draw your attention to 10, 11, and 12, because this is where things, and if you have questions on this, please ask, get a little confusing. The code itself is a range. So for a 10, for instance, we've got 5 to 10 particles. Now, when we go to a code 11, it's 10 to 20 particles. And then from a 11 to a 12, it's 20 to 40. Notice every time we jump up, we double the delta between those two numbers. So the easiest one, again, 11 and 12. So 10 to 20, there is a 10 spread there. And then from a 12, it's 20 to 40. So we add another 10 particles within that range. And it does this doubling effect all the way up to 24. So why I kind of bring this out is when we're working with customers and say they have a high ISO code, like over on the right side, you see that picture there of a 24, 22, 19, what that patch looks like. And then you look below it and we have a patch of a 16, 14, 11. Just when you're looking at the drop in ISO codes, you may not think that, hey, that's a huge difference. But from a particle standpoint, it is a dramatic difference because of the way the codes double as they go up the range. And I used a 24, 22, 19 and a 16, 14, 11 to kind of show those two patches that I had. But even if I say take you from a 22, 19, 17, and I bring you down to say a 20, 18, 14, if you look at a 22, which would be your 4 micron particles, and I'm on the high end of a 22, which is 40,000 particles, and I drop you to say a 20, and I'm on the low end of a 20, now I'm at 5,000 particles. That's a dramatic change in the particle count within that system. Now at the very bottom, highlighted in yellow, I have some really big numbers there. When we do these ISO codes, it's all based off 1 milliliter of fluid. So if you look at that 24, 22, 19, and you see on the chart, particles per milliliter, and you look at the 4 micron channel, they actually call out how many particles they found. And that's 151,773 particles. Now that's that amount in 1 milliliter of fluid. So how many milliliters are in a gallon? Well, 3,785. So when we're looking at that as to 1 gallon, that number gets really large really quick. And now think about in your lube oil system or your hydraulic system, how many gallons you have. And you can do the math. It starts to get a little mind-numbing how large these numbers get over time. So the next thing we have a lot of customers kind of poke us on is beta ratios and then how they relate to efficiency. So if you're not familiar with the beta ratio beta ratio test, the way they quantify this is it's the number of particles that go into the filter divided by the particles that come out. So for instance, a beta rating of 200, which used to be the standard, that's 200 particles make it into the filter, 1 particle comes out. 1,000, again, 1,000 particles go in, 1 comes out. Now, when we look at the chart to the right there on efficiency, if you look at, say, a beta rating of 1,000 and you compare it to a beta rating of 5,000, from an efficiency standpoint, the difference is 0.08%. So when you think about, wow, I mean, what's the difference in efficiency? It doesn't sound that big as to when you actually look at the beta rating and say, well, I'd rather have a filter that'll filter out 5,000 particles than 1,000 particles. So just trying to make sure we understand that. Right now, the beta rating for our high-end filters with Hypro is around 4,000. That seems to be where the industry from a fluid and lube oil system are going, is to that 4,000 beta rating. There's still a lot of thousands and 2,000 beta ratings out there. 200, again, 10, 15 years ago used to be a pretty decent filter. Those have pretty much been pushed to the side when we went from cellulose to microglass media. Now, the way the beta rating was developed was through a certain system. That system, we induce particles on one side, we go through a pump, we count upstream particles of the filter, so we know how many particles go in. So, for instance, a beta rating of 1,000, we count 1,000 particles. We go through the filter, we have a particle counter downstream, and we count the particles that come out. When we're doing the beta rating test, this is all done on steady flow and steady pressure, which is unlike a hydraulic or lube oil system. So with Hypro, we've developed what we call DFE, dynamic fluid efficiency, where we actually vary the flow and vary the pressure through our filter until the filter is 95% plugged. And then once it's 95% plugged, we shut the system down, and then we do a rapid startup with full pressure, full flow, mimicking a rapid startup procedure like you would see in your facility. The reason we do this is because with glass media and cellulose, they have what we could call filter unloading, or they catch a particle, and then with fluctuations in that system, the glass media or the cellulose media is able to flex, and when it flexes with those changes, particles get pushed out into the system. Hypro is on our 8th generation of media, and we're still looking at ways to better handle these changes in flow so that we catch a particle and hold it. But that's our secret sauce when we say that our filters are, one, they last longer than any of our competitors in the same application, apples to apples. And then we also clean in the same application, apples to apples, better than anybody else. It's because we account for what we're calling filter unloading. And I've got a quick video of what that actually looks like in a system. This is the inside of a filter. As the pressure's changing, you can see all those contaminants getting pushed right back into the system after there's a fluctuation in pressure and flow. So what can we do from a diagnostic standpoint to kind of stay ahead of these particle changes? You can do online particle counting, which is like that PM1 to the far left. You can also do online particle counting with a particle counter that somebody can bring out. At Adams, we use the Hypro PFM75. It has a built-in pump, as well as we can use a pressure port in your system to bring your fluid in and then dump it back into your tank, or dump it into a 5-gallon bucket and test your oil there live and give you a particle count. And then finally, there's fluid analysis. So you can pull a sample and send it off to a lab. Now, one thing from a fluid analysis standpoint, we get asked all the time, what's the best way to take a sample? Because this company came in and said I should take the bottle and shake it 4 times and then dump it, and then I should do, put it in a fridge or do something crazy. And then another person said do this, and now Adams is coming in and they're telling me to do something else. The main thing that I try and get across to customers is that it's not necessarily who's right. It's that we find a good place on your system to pull a sample from, and then we determine if that place needs to be flushed because contaminants will compact into those areas, and how much do we need to flush it so that we can get a great representation of what's actually living in your system. And then once we determine that place where we're going to take a sample from, we also need to determine how do you want to take that sample. If you want to do it X, Y, and Z way, pour the fluid in the bottle, shake it once, dump it out, pour the fluid in the bottle, shake it again, pour it out, and then take the third sample. I'm fine with that. The one thing that I would most recommend is that if you have Joe take a sample on Monday and he does it one way, then the next time you pull a sample to compare, that next person has to do it the same way he did. So standardizing you and your team on how the sample is taken so that we can take that data and trend it over a long period of time. And now that's something that, back to having Norm on staff and Adam's doing fluid cleanliness trainings at your facility, that we can help you determine when we're on site. And then we also come back quarterly and re-up anybody who's new on the team to kind of follow those guidelines so that everybody's taking the samples the same way so that we get great trendable data. Now, this life expectancy chart here on the side, I want to say this came from Vickers back in the day. They did some testing and found out that as we lower ISO codes, what does that look like for component life? So if you remember earlier, we had this 24/22/19 and we had a 16/14/11 ISO code. So you see the differences there in that patch again. What does that look like from a life expectancy? So if you look at the ISO code chart on the first column, we don't have a 24, but we do have a 25/22/19. And if you look across the row, you can see that there's a 16/14/11. So if we take you from that patch you saw earlier to that cleaner patch, effectively every component in that system should last 4 times longer. This is why all the big boys in the industry, heavy industry, have been really focusing on how clean is my oil and how can I get that ISO code lower, because they're finding out life expectancy is longer, which will help with unplanned downtime and keep them on their uptime. So that was particles. I know I went through it real fast. We only have an hour, so trying to do very top level. Nate, was there any questions?
Yeah, there's one point that was made, and what this attendee said, that depending on the supplier, the fluid could be cleaned before it arrives. So is that something that you have seen? I imagine there might be some additional cost or lead time, et cetera, but that was something that they brought up. So I just wanted to bring it up to you as well.
Yeah, and I've heard stories of, and we actually did one for a company where the distributor of the oil, and it was Shell in this case, actually bought a skid from us because they had to guarantee clean oil to the end user. Some factories are doing it. To tell you which one, you would have to ask your oil supplier if it is cleaned. And then I would also back check it because, how did they clean the truck out before they put the oil in there? What oil was in the truck before it? There's still a lot that goes in to that. One thing I could point you to is I just randomly went to a Tractor Supply and bought some standard hydraulic oil off the shelf and did some ISO code testing live on YouTube, on my YouTube page. And it had I want to say it was like a 22/21/19 ISO code with heavy particles in it. So yeah, you would just have to ask your oil provider, are you doing this type of cleaning, and when you're doing the cleaning, when is it done and where is it done? Because like I said, if it's right as it comes out of the bulk tank and then it goes into a truck and then a truck to a 55-gallon drum, how are they mitigating contaminants, doing all that transferring? So great question.
Yeah, I think the key point there is to have that conversation with your supplier if you aren't already, and then proceed, as necessary. All right, exactly. That was it. You can proceed to the next section, sir.
Perfect. All right, next one is water. So let's look at water and how we might know that we have it, and then also what it causes. So oxidation could be a leading indicator that you're having a water issue. Foaming, excessive foaming, sludge formation, cavitation of pumps that you didn't have before, but yet the pump's been rebuilt, or we put a new pump in and you're still getting cavitation, bearing system damage. All these things are leading indicators that there could be an issue with water in your system. Causes of these ingressions, they range. It really depends on where your system's located. Condensation, we are in Florida. Sometimes we have really cold mornings and we have really hot afternoons. So that change in temperature could cause some condensation. Rain, paper mills sometimes are notorious for when it rains, the gearboxes that are out on roofs or somewhere where there's not a way to shield them from that rain can work their way in. Just standard routine washing of the equipment. If you hit it with a pressure sprayer just right, it gets up under the seal, you can get that in there. Again, cylinder leaks, kind of like contamination. If you got cylinders that are leaking and there's moisture or water around, it could get in there. You could have a water-cooled heat exchanger, and those things fail pretty much regularly. If you're at a steam turbine, steam leaks are very common and pop up out of nowhere and can cause large amounts of water into systems. And then finally, we're all human. It can go back to human error. Somebody made a mistake and water got into the system, and rather than condemn that fluid because it's expensive, you want to try and reclaim it. So there are three main forms of water. There's dissolved, which is that first one you see there. Kind of looks like the fluid's okay, but you're still getting, when you send out for oil reports, or you're having some issues that are leading you to think that there's water that we explained earlier, that would be dissolved. The water molecule is fully dissolved within that oil itself. There's emulsified. That's the one that you take a sample and it's milky, and sometimes it can separate out after days, but for the most part, it's just a milky color. It's not fully dissolved into the oil, but it's attached to that oil molecule and it's really not wanting to let go. And then there's free water. That's the one you pull a sample and it may look milky and you set it on your desk, and in about 20 minutes, you look back at that sample and you see the water at the bottom and you see the oil at the top. That would be your free water. So what's the way that we recommend to test for this? First off, is the crackle test. It's really not the most accurate of tests, but if you're in a pinch and you need to figure out if you have water, just using a hot plate, putting a temperature up to 320 degrees, and you'll start to see that water want to bubble and evaporate out. That lets you know that you would have some water in that system. I've found recently that a lot of equipment, whether it be contamination equipment or your equipment that came with your system, has relative humidity sensors on there. So looking at your percentage of relative humidity, and as that relative humidity goes up, you can tell that I'm starting to get an issue with water. And then finally, getting that true parts per million using a Carl Fisher test. So kind of going back to the particles, when you pull a sample, you can have that sample also tested when you send it to the lab for the Carl Fisher test, and that'll give you a true ppm of parts per million in water that's in that fluid. Now, with Hypro, we are lucky enough to have 3 different forms of water removal when it comes to what you have in your system. And so the first piece of equipment is a vacuum dehydrator. The vacuum dehydrator is basically we heat up your fluid to about 133 degrees here in Florida because of our atmospheric pressure. And then we pull a vacuum on that oil. And when we pull a vacuum on that oil, what it does is it lowers the boiling point. And at a lower temperature, we're able to flash that water off. And the reason we do this is because, you know, your oil can't live at temperatures where we need to boil the water off. So using vacuum technology to lower the boiling point helps us flash that water off. And generally it comes off as vapor. We also have coalescing technology where you have a coalescing element. Easiest way to explain it, that element is hydrophobic. So oil will want to go through the element, but the water molecules will not want to. They'll want to repel themselves from it. So that's how we shed that away. Once it sheds away from the element, it falls down to the bottom and you can bleed that water off. And then the last piece of equipment is headspace dehydration. What we do is we blow a clean source of air across the headspace or nitrogen. We have two versions, a nitrogen version and a air version. We blow that clean, dry air or nitrogen across the headspace, and it's called mass transfer. But the easiest way to kind of explain it is the water molecule that's attached to the oil would rather be with that clean, dry air or nitrogen. So it unattaches itself from that, attaches itself to the nitrogen or the air, and then we blow that water out of the headspace as a vapor. Now, each three of these pieces of equipment all have a specific use in a specific situation. Vacuum dehydration, I like to tell customers that gets all three forms of water out. And not only does it get them out, it gets them out quickly. So gallons and gallons of water a day we can remove with a vacuum dehydrator. Whereas a coalescer will only get your emulsified and free water, but it will also do gallons of water a day. And then lastly, that headspace dehydrator, think about it as cups a day, not gallons a day. So if you have a small leak over a long period of time and you want to manage that through headspace dehydration, that's kind of where that one fits in. So depending on what issues you have, please get with, you know, either one of your Adams reliability specialists or have them get up with me and Norm, and we can come out, look at your system, and kind of work with you to make a determination of what piece of equipment might be the best for your application. So real quick, I just wanted to touch on a case study we did at a customer years ago. They had a water leak get into one of their reservoirs that was a couple hundred, well, 600 gallons of fluid. This fluid was actually very expensive and they didn't want to condemn it if at all possible. So we actually, again, just throwing out there, we do rent equipment. We do rent a bunch of vacuum dehydrators throughout the state of Florida. This customer rented a piece of equipment from us. We got it on site. We did the startup, and within 18 hours, we had changed from the before and after pictures you see there on the right. The customer kept running this for about a month, 2 months, and was able to save that fluid without having to do a change out or a flush that could be more costly than what the rental cost was. All right, Nate, that was end of water. Wonder if we have any questions.
Looks like we're good. You can keep going, buddy.
Sweet. All right, and the last one is probably one of the newest out there. It's varnish. You know, this is probably going to be a little more tailored to the turbine industry, power plant industry. But what we found out over the last 10, 15 years is that varnish has actually started to creep into other areas. The gas and turbine industry pointed us towards this issue, but we're starting to find it in plastic injection molding machines, gearboxes and paper mills and different facilities are starting to see some of the same issues that these turbine users have been seeing for years. And we're starting to get a better handle of how to handle varnish and then also identify it. So let's look at some telltale signs of what would think you or cause you to believe that you might have varnish. Filters plugging prematurely, actuators having a sluggish or slow movement, mechanical equipment just getting stuck. Equipment that had never been stuck in the past all of a sudden now is having issues and doesn't function like it used to. Usually this is on lube oil systems. That would be an indicator. The biggest one would be servo valves. What we're finding out is when varnish plates out in these pictures that you see on these metal items, they like cool surfaces. So they like metallic because it can be a cooler surface in the system than anything else. So servo valves, heat exchangers, radiator, not as much as water cooled, but both of the radiator and the water cooled heat exchangers are great indicators of do I have varnish in my system. Here's some other pictures of different types of varnish. So varnish isn't a sludge. It could be many different things. It could be a layer of film on the top of your reservoir. It could be sticky sludge cake on your reservoir, your pipes. It could be hard caked, brittle chunks within the system. So it's not just like a gooey sludge. It could be multiple things. So varnish testing. This is where, unlike water and unlike particles, it's a little tougher for us to say you have varnish. The only way to truly know if you have varnish in your system is to open your system up like we saw on these items and physically see that brown or gold tarnish on metal parts. What we're doing when we're testing multiple different things to try and piece together a puzzle of what could be leading indicators that you have varnish in your system. So usually when I work with customers and I ask about varnish, they go, oh, well, our tan is good. Well, just because you have a good tan doesn't mean you do not have varnish. There are other things we want to look at, and I'm going to go over a couple of those things here quickly with you. And this is just a good representation. We do varnish testing for our customers. If you can do varnish testing through your current oil supplier, again, we do represent Hypro. We are a filter company, so sometimes keeping us agnostic from that testing helps give you a peace of mind that we're not doing anything funny on our end, but we can help walk you through with your oil supplier what tests we're looking for to kind of give us that roadmap of, hey, you probably do have varnish. Here's where it's at. Let's kind of attack it this way, because there's a couple different ways to attack varnish depending on if it's soluble or insoluble. So again, your total acid number, that's great to look at. It's looking at component degradation over life. So looking at your tan, as that tan rises, that could be an indicator. One that I don't see on regular tests is the SAN, or the strong acid number. This has got a little higher acid than the total acid number. So it has a little more oxidation in it, a little more corrosiveness to it. So also looking at that as well. And then water content. Elevated water content within your system helps degrade the system and just promotes corrosion and wear. We also want to look at viscosity. So resistance to flow could be another thing, a leading indicator that varnish could be within your system. And then demulsibility. So the fluid's ability to separate from water. So we talked earlier about vacuum dehydration. When your demulsibility in your oil begins to go away, it's harder and harder for us to use any type of technology to reclaim that oil. One thing that we found with some of Hypro's technology is that we're able to restore demulsibility through ion exchange bonding with resin. So if your demulsibility goes low and you're thinking, hey, my demulsibility is low, Adams told me my demulsibility is low, my oil company's telling me my demulsibility is low, I'm going to have to trash this fluid and start from new. Well, we found out over the course of a couple of years that with ion exchange bonding, we're able to actually beef up that demulsibility and get it back into spec so that you don't have to condemn that oil and trash it into a flush. And then finally, resistivity. This is commonly for turbine phosphate ester, but it's the electrical that the ohms that's within inside the fluid itself, which could start to affect how servo valves react in the system. And then we've got the MPC test. So that's the membrane patch colorimetry. Basically what we do on that, it's kind of like pulling a patch for particles. We take a fluid, we run it through a fine filter. What we collect on that filter gives us a representation of a color change of what the new fluid should have looked like to what your fluid looks like in your system. And then we put that on a spectrum and show you that change. And then last, patch weight. So then we would take that patch and weigh it, because there's two avenues of thought there. When you do the colorimetry, you're looking at insoluble varnish, whereas patch weight, we're looking at that soluble varnish in your system. So think of it as in solution as opposed to out of solution. MPC is catching those that have fallen out of solution. Patch weight is trying to determine what is still in solution that we're not able to get a color spectrum on. Now, along with this, one of the things we found that is misleading to customers is that some labs are doing a cheaper MPC test where they're not following the ASTM standard. I would, if you're not going through Adams and you're just going to send this off to a lab and you're going to say, hey, I heard Adams talk about an MPC test. I want to do one of those and see what mine comes out to. Make sure they're doing the ASTM standard. Basically, we hold that oil for 23 to 25 hours heated, and then we keep it at room temperature for about 68 to 76 hours for incubation, while keeping it in a dark room because light can affect these samples as well. So we don't want to induce any light to those samples so that it doesn't get affected. I bring this up because we had a customer that we knew varnish was in their system. We could see it when we took the system and opened it up, but they kept getting their MPC test back and it was coming back completely fine. And what we found out was that the customer was actually pulling samples when the system was cold. So they were getting a cold sample and then they were leaving it in a cold room for a long period of time before sending it off. When we had the system running and it was hot, we pulled the sample, we sent it off, we did the ASTM standard, and we got a completely different MPC test out of that same fluid, just because we could visually see in the system that there was varnish there, but we were not being able to tell if there was varnish through the regular routes. And that was just because of that hold time from the ASTM standard. And just to note, varnish will stay in solution or soluble at about 120 degrees or greater, and it wants to fall out of solution and become insoluble at about 120 degrees and lower. And that's also, as I'll talk in the next couple of slides, how we kind of go after varnish when we're trying to remove it. We have to cover both ends of those spectrums from a temperature standpoint. And then last, the ruler test, comparing the antioxidants. So with inside your system, you're going to have your amines and your phenols. Those amines and phenols, when varnish is present, they start to attack that varnish, and we start to deplete those two. And as those two deplete, we start to lose the useful life of that fluid. While with demulsibility, we can regain your demulsibility. With amines and phenols, we don't have a way to regain your amines or phenols unless you just want to put an additive package back in, which is not recommended because of the way they blend them, or if you top off the fluid. What we can do is, by using contamination equipment to attack varnish, we remove that varnish out of the system so that your amines and phenols are not having to attack that. They can keep on doing what they're supposed to do within that fluid's makeup. So here's just a quick visual of an MPC test. You've got your L strain here, which is for your, if you see this, you've got a phosphate ester. That's what that L relates to. And then generally, if you don't have a phosphate ester based fluid, you're just going to have your A and your B channels. And you can see how quickly that you can go from a clear patch to a very dark colored patch fairly quickly over a course of months. And so how we attack these, years ago we thought electrostatic was the way to get these to take that oxidation byproduct and get it to attract to something. We found that yes, you can mechanically filter out, for lack of a better term, that varnish, but again, it would have to be insoluble. So we have what we call VTM media that is basically a mechanical filtering process where we take out the insoluble varnish. Again, insoluble varnish is generally 120 degrees or less when we're talking temperature. And then if we're above that, system's running, you're probably looking at ion exchange bonding, where we use resin to attract that soluble varnish to the resin bead, and then that varnish and that oxidation wants to attach to that resin as opposed to staying with the oil and going back into the system. Now, what online varnish removal does for you, the customer, is one, we can do this while it's online. You don't have to do an expensive flush of your system, or you don't have to dump your fluid and then refill it. We can do this completely online. And then what it's allowing you to do, if you do a dump and flush, well, if you do a dump and then you refill and you're not going to do a flush, you're still going to leave varnish within all the piping in your system, your valves, your cylinders, everything. So when you put that new fluid in and it makes its first pass through the system, it's going to start to grab all that old varnish, and it's going to start attacking your wear package on your fluid. And then also you're bringing it right back to the tank, and then the varnish process is going to start all over again. Same thing that we talk to customers about, these additive packages that they say, hey, we can just throw in an additive package, or we can just do a bleed and feed. Well, when you do those two things, all you're really doing is just kicking the problem down the road to come back and bite you. Could be months, could be years, but you're eventually going to get the same problem coming back. When we do online filtration with the VTM and ICB media with one of our skids, not only are we cleaning up your reservoir, but as that cleaner fluid's going out and grabbing varnish that's been caked on your parts and your valves, and it brings it back, we're filtering that out as well, guaranteeing that you're not going to have to do a bleed and feed or a chemical add down the road. We do rent these systems, and then we also sell them as well. So just a quick case study that we did at the end of last year. Went and visited a customer. This happened to be a turbine application. It wasn't phosphate ester. It was just a regular, I want to say it was GTE 32 fluid. And they were having a pretty bad varnish in their system. We looked at their oil reports. We took some samples, sent them off to EPT. The one thing we did with these samples were with the varnish that we were seeing in the system, we wanted to guarantee that our ICB resin was going to be able to remove that varnish without any issues. There's nothing worse than having a varnish issue and buying a piece of equipment and it not working. So we wanted to go ahead and check that up front for the customer. So we sent those samples off. We got it all checked out. While we were looking at their oil reports, yes, varnish was an issue, but their ISO codes were fairly high as well in the system. 221915 is what they were living at. So we got them a skid by the end of December. And within 3 weeks, we had dropped that MPC value from a 26 down to a 5. And then we also dropped the particle count from a 211915 down to a 151312. All these numbers came from their fluid analysis company, not from us. We did some testing on our end to just verify that our ICB resin and our VTM would pull out the varnish, but that was the only testing we did. These numbers came strictly from that customer. This was a huge win for that customer. They're having varnish issues in other places, and after seeing this, they've now asked us to come back and start looking at some other systems that they're having issues with. And with that, I think I made it under the hour mark.
Thank you all for attending. We greatly appreciate it, and we hope you all have a great rest of the day.
Yep. Thanks, everybody.
Thank you.